To calculate the area of a curve given in parametric coordinates, so let's suppose that our curve look like this, for instance, and we want to calculate the area under this curve between the values A and B. Well, we know that these values A and B are going to correspond to certain parameter here, let's say T0, T1. And so if this function were just a function like the ones that we have in calculus, like y depending on x, so then what we want to calculate for the area would be simple, the integral between a and b of f, right? That depend on x dx. But we know that in parametrics, the functions are given in this way, right? So the x depend on a parameter t, and the y also depend on the parameter t. And so this integral is going to be actually, the area is going to be actually the integral from the first value of t to the last value of t. Of what? Well, first f of x. Well, the function is just going to be equal to y, so that's what we're going to write. So the y that depends on t. So that's the function that we're going to write there. Times the dx. So let's see how much is the dx. We know that x depends on t. So doing the differential in both sides of this equation, we will have that the dx is actually equal to x prime dt. And so that's what we're going to put instead of the dx. So this is going to be times x prime dt. And this is the formula for the area in parametrics. So we have to calculate the integral between the first and the last value of t that we want, and we put in the integrand the y and the derivative of x. So let's see how this works in an example that we want to calculate the area of this cycloid. Between the values of t, let's say between 0 and pi, for instance. So this is a curve that we can give values in our chart and draw a graph. I mean, let's, for instance, plot the value 0 here. We have that the value of x will be 0 minus sine of 0 is going to be 0, and the value of y will be 1 minus cosine of 0, which is 1, so 1 minus 1 is also 0. And so we have that the first point that we can plot for the function is 0, 0, so it's going to be here. And we plot different points and we will see that this function is going to look like this. And we can also draw it in Sage. This is just a little reminder of how to plot functions in Sage that you should be doing constantly with all these functions. So we want to calculate the area between 0 and pi. So let's say that pi is some number that is, I don't know, around here. And so the area that we are trying to calculate will be this one. Well, according with the formula, the area will be equal to the integral between 0 and pi, right, the values of t that are given here, of y, that in this case is 1 minus cosine of t, times the derivative of x, which in this case is going to be 1 minus the derivative of sine is cosine. Okay, so that was the y, and this one was x prime, and so dt. So at the end of the day, we need to calculate the integral from 0 to pi of 1 minus cosine of t squared dt. And well, now you just calculate this integral using all the techniques of integration that we already learned. And so this will be the integral between 0 and pi of, we expand this square here, so that will be 1 minus 2 cosine t plus cosine t squared dt, and now we separate this in these three terms and integrate each one. So the integral of 1 is t minus 2, the integral of cosine is sine, plus, and the integral of cosine squared, we have done it many times, integration by parts, the integral of cosine square of t, we can put directly that is t plus sine cosine, right, over 2. So this is the primitive of this function, and now this should be evaluated between 0 and pi. When we evaluate at pi, we obtain pi minus 0 plus pi plus 0 over 2 minus, when we evaluate at 0, everything here is 0, so at the end of the day this is just pi plus pi over 2, which is 3 pi over 2. So this is the value of the area that you can calculate approximately how much it is, right? So this is about 3 times 3, which is 9 over 2, so a number a little bigger than 4.5. That's the area of this function then.